So, hello, very good morning to all of you. Right. So, in this class, we are going to discuss some questions related to GOC. Right. In previous class, also we are cover some question related to GOC, in which we cover question related to inductive effect, electromagnetic effect, IUPAC naming, and some carbocation, carbon questions. Right. So, in this class, also we are going to see some more questions. So, this is going to be a very interesting. So, all of you फटाफट ज्वाइन कर लो जल्दी से और फिर हम लोग बहुत अच्छे अच्छे क्वेश्चंस को डिस्कस करने वाले हैं राइट। चलो सो स्टार्ट करते हैं आज का सेशन अपना, क्योंकि बहुत इंपॉर्टेंट होने वाला है। काफी अच्छे अच्छे क्वेश्चंस हैं जो हम लोगों को इसमें सॉल्व करने हैं राइट। चलो सो द फर्स्ट क्वेश्चन इज दैट इज द डिक्रीजिंग ऑर्डर of acidity of the following carboxylic acid, right? So in this they are asking what is the decreasing order of the acidity of the following carboxylic acid. So we have A, B, C, D, E, D, E, right? We have a five option, and out of five you have to arrange them in the decreasing order of their acidity. So basically, if you talk about the acidic, then in which factor this acidic values depend, right? So basically, this acidity of carboxylic acid is dependent upon the whether electron withdrawing group is attached to it or not, right? Whenever electron withdrawing group is attached, always remember beta, electron withdrawing group. So whenever this electron withdrawing group is attached, it always increase acidic character. So ये हमेशा क्या बनाएगा, acidic character को increase करने वाला है whenever electron withdrawing group attached to the carboxylic acid or any carbon atom. Similarly, when electron donating group, that is EDG, when electron donating group is attached, then they always decrease the acidic character, right? They always decrease the acidic character. So this thing is very important to learn. Okay. Now we know this out of this five thing, we know CH3, right? This CH3. So which one is electron donating and which one is electron withdrawing group? How will you identify, right? So we know this that is CH3. So CH3 is an electron donating group, right? CH3 is electron donating group. So they having electron donating group. Similar F3C have a strong electron withdrawing group. So we know this F, we have a F3. We also have a Cl. We also have a F and Br. So out of these, we know that if the more number of electron withdrawing group are attached now, then definitely the electron withdrawing capacity is more, right? Because the more number of electron withdrawing group is attached. So the acidic character is maximum. So the acidic character is maximum for which of the following? Obviously, the acidic character is maximum for the B, right? Because here maximum number of electron withdrawing group is attached, and the minimum where electron donating group is attached, that is for A. So the order is like B is maximum and A is minimum, right? So rest all lie between these. Now let's talk about the Cl, F and Br. So out of Cl, F and Br, we know that F and Br and Cl. So this is the fluorine, chlorine and bromine. So out of these three, which one behave as a good electron withdrawing group? So always remember beta, that is bromomethyl group. So it has the same electron withdrawing ability due to the electron activity, just like the fluorine atom, right? But it is less than the chlorine and fluorine. So the order is like fluorine, chlorine and then bromine. So fluorine is the maximum electron activity, therefore they are having the maximum electron withdrawing group capacity, and bromine having the minimum out of these three. So the correct order is that is B. After B, we have D, right? And after D, we have that is C, huh? And after C, we have E. So this is the correct order. That is B, D, C, E, A. So out of this, which option is correct, beta? That is B, D, C. So B, D, C, E, A. Yeah, that is option C. तो ऑप्शन सी बिल्कुल ही करेक्ट है इसके लिए, ठीक है। सो ऑप्शन सी बिल्कुल ही करेक्ट है इस क्वेश्चन के लिए। सो आई होप सबको समझ आ गया होगा ये क्वेश्चन कि किस तरीके से हम लोगों ने अरेंज किया, दैट इज द डिसेंडिंग ऑर्डर ऑफ द एसिडिटी फॉर द कार्बोक्सिलिक एसिड। सो दिस इज द वे हाउ विल यू एक्चुअली अरेंज द फॉलोइंग अकॉर्डिंग टू देयर एसिडिक कैरेक्टर, ठीक है। चलो नाउ मूव टू द नेक्स्ट क्वेश्चन। सो अगला क्वेश्चन क्या बोल रहा है हम लोगों को, resonance in carbonate ion is, and which of the following is true? So you have to identify out of these four options which of the following is true, right? So the first option is given that it is possible to identify each structure individually by some physical or chemical method. सेकंड बोल रहा है ऑल दिस स्ट्रक्चर आर डायनेमिक इक्विलिब्रियम विद ईच अदर. नेक्स्ट बोल रहा है ईच स्ट्रक्चर एग्जिस्ट ऑफ इक्वल अमाउंट ऑफ टाइम. एंड डी बोल रहा है CO3 हैज अ सिंगल स्ट्रक्चर रेजोनेंस हाइब्राइड ऑफ द अबव थ्री स्ट्रक्चर. सो बिल्कुल सही बात है बेटा, जो भी रेजोनेंस स्ट्रक्चर शो करता है तो इसका एक क्या बनता है, रेजोनेंस हाइब्राइड स्ट्रक्चर बनता है. अब वो क्या होता है रेजोनेंस हाइब्राइड? तो रेजोनेंस हाइब्राइड कुछ इस तरीके से होगा कि इसका अगर हम रेजोनेंस हाइब्राइड देखें, so resonance hybrid is like this, that is this one and this one, right? And all of them having a, yeah, partial double bond character, right? So this is a resonance hybrid structure. So this is a resonance hybrid structure of this carbonate ion. So क्या बोला है इसमें कि CO3 has a single structure and resonance hybrid of these element, right? So ऐसे समझ सकते हो कि it is CO3 has a single structure that is resonance hybrid of the above three structure. So option D is absolutely correct for this question, right? चलो move to the next question बेटा, that is, हाँ, next question is the correct order in aqueous medium of the basic strength. So you have to identify the correct order for the aqueous medium, basic strength for the aqueous medium, right? So we know a very important thing, that is on which factor the basic strength basically depend, right? So we have in this we have one ammonia, right? And one we have primary amine, that is CH3 and NH2. Secondly, we have secondary amine like CH3, NH and CH3, that is secondary amine. And we also have a tertiary amine like CH3, N and CH3, again CH3. So we have ammonia, primary amine, secondary amine and tertiary amine. And out of these, they are asking the correct order in the aqueous medium of the basic strength, right? So here, very important concept, right? If aqueous is not mentioned, let us assume if you have to calculate the basic strength only, not in aqueous medium, other than aqueous medium, then you need to just see on plus I effect creating group, right? Because we know that as the number of plus I effect creating group increase, basic strength also increase, right? And similar, if the minus I effect, that is electron withdrawing group, is attached, then acidic character will be increased. So if they are asking their basic strength other than aqueous medium, then you need to grab only one concept, that is plus I effect. So we can easily understood this in this, that is in a tertiary amine we have a maximum number of electron donating group. Hmm? Maximum number after this secondary. So the order is like 3 degree, 2 degree, 1 degree, and then comes ammonia. So this is the order of basicity in non-aqueous. If there is no aqueous is present, no aqueous medium is present. Now, if this aqueous comes into the picture, then you have to consider this both effect. That is plus I effect you need to consider. This is very important, as well as next is as well as the hydration effect, right? So whenever this thing comes, you need aqueous solution, आपको दो दो चीजें कंसीडर करनी है. एक तो प्लस आई इफेक्ट भी कंसीडर करना है, इसके साथ ही साथ सॉल्वेशन इफेक्ट को भी पिक्चर में लाना है, दैट इज सॉल्वेशन. अगर वही ये क्वेश्चन ऐसे होता बेटा, कैसे होता कि उसमें अगर आपसे ये नहीं पूछता कि वो एक्वस मीडियम है, सिर्फ बोल देता बेसिसिटी बताओ, क्योंकि हम तो जीओसी पढ़ रहे हैं ना अभी, हमें माइन चैप्टर नहीं पढ़ा हम लोगों ने. तो जीओसी में तो हमने प्लस आई और माइनस आई पढ़ा है. तो उसमें हमें पता है कि अगर प्लस आई इफेक्ट बढ़ाएंगे अगर हम प्लस आई इफेक्ट ग्रुप जैसे इलेक्ट्रॉन डोनेटिंग ग्रुप लगता है तो हमेशा बेसिसिटी को बढ़ाएगा। तो ऑब्वियसली बात है, टर्सरी अमाइन में देखो 3 बेसिक डोनेटिंग ग्रुप है, तो ऑब्वियसली दे आर मच मोर बेसिक। लेकिन यहाँ पे क्वेश्चन में एक एक्वस वर्ड डाल दिया, ठीक है। तो एक्वस वर्ड में आपको प्लस आई इफेक्ट तो कंसीडर करना है, एज वेल एज सॉल्वेशन इफेक्ट को भी कंसीडर करना है, ठीक है। सो उसके हिसाब से ऑर्डर क्या हो जाएगा, तो ऑर्डर इज लाइक सेकेंड डिग्री, then 1 degree, then 3 degree, and then ammonia. So this is the order in the aqueous medium. So always remember, in aqueous medium, order is like this. In non-aqueous medium, order is this. Okay? So this is for non-aqueous and this is for aqueous medium. Clear है? समझ आया सबको? एक बार बता दो. Aqueous and non-aqueous के लिए. Done? Chalo, very good. So this is for aqueous and non-aqueous. So this is the correct order. That is 2 degree, 1 degree, 3 degree. So which option is correct, beta? Yeah, that is option number C. 2 degree, 1 degree, 3 degree, and then comes ammonia. Chalo, move to the next question. So given below are the two statement, and one is level as assertion and other is level as reason. So you have to identify whether the assertion reason both are true or one is true and one is false. And vice versa, right? So let's see what is assertion. So benzene is more stable than hypothetical cyclohexatrine. तो कह रहा है कि benzene is much more stable than cyclohexane triene, right? And the reason is the delocalized pi electron clouds it attracted more strongly by nucleus of carbon atom. So you have to identify above two statement which statement is correct. Right. So let me explain the first thing. That is benzene is more stable. So we know the structure of benzene, right? So the structure of benzene is like this, right? So this is benzene. So benzene is much more stable than hypothetical cyclohexatriene. So cyclohexatriene समझ रहे हो क्या ये? Cyclohexatriene, right? मतलब साइक्लो है और हेक्सा भी है और उसमें ट्राईइन है। सो है तो सेम ही कॉम्पोजिशन, लेकिन वाई? So ध्यान से समझो, बेंजीन इज मच मोर स्टेबल देन हाइपोथेटिकल साइक्लोहेक्साट्राईन ड्यू टू द डीलोकलाइजेशन ऑफ इलेक्ट्रॉन इन द पाई इलेक्ट्रॉन क्लब। क्योंकि बेंजीन में डीलोकलाइजेशन किसका होता है? इलेक्ट्रॉन का, राइट। द डीलोकलाइजेशन ऑफ इलेक्ट्रॉन लीड्स टू मोर स्टेबल इलेक्ट्रॉनिक कॉन्फ़िगरेशन इन बेंजीन as electron are shared more evenly between all 6 carbon atom in the ring. So we can say that the assertion is very much true. ठीक है? This is a hypothetically cyclohexatriene होता नहीं है कुछ ऐसा, ठीक है। तो hypothetically cyclohexatriene कोई बोले और कोई बोल रहा है benzene. So benzene is much more stable because यहाँ delocalization of electron is possible, right? And this delocalization of electron leads to the most stable electronic configuration in the benzene. So the assertion is very much correct. And what is the reason behind this? That is the delocalized pi electron clouds is attracted more strongly by the nucleus of carbon atom. So here both assertion and reason are correct, right? So here both A and R are correct, and reason is the very much correct explanation of A, right? So we can say that both A and R are correct, and R is the correct explanation of A. So this is very very important. ठीक है? So I hope सबको समझ आ गया होगा. Anyone having any kind of doubt till you can ask. Clear है सबको? चलो. Now the next question is that is uh the correct order of priority of functional group in organic. ठीक है? The question compound as per the IUPAC system of the nomenclature, right? So you have to arrange them in the correct decreasing order of the priority of the group, right? So this is also very 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 important question. that while naming which will give us the preference, right? Because in preference method only then we came to know which one behave as a functional group and which one is behave as a substitute. अगर ये प्रेफरेंस का ऑर्डर पता होगा तभी आप लोग आइडेंटिफाई कर सकते हैं कि अगर मोर देन जैसे एल्डिहाइड भी हो गया, कीटोन भी हो गया, एस्टर भी हो गया, तो आपको किसको फंक्शनल ग्रुप मानना है और किसको आपको सब्स्टिट्यूट की तरह यूज करना है. सो दिस you know only when you know the priority order, right? So ये प्रायोरिटी ऑर्डर का पता होना बहुत ज्यादा जरूरी है. तो चलो देखते हैं सबसे पहले क्या है प्रायोरिटी ऑर्डर हम लोगों का. That is the correct decreasing order of priority groups in naming an organic compound. ठीक है. So we all know this. The order of decreasing a priority for the functional group is like this. This is the correct order, beta. That is maximum for COH. So this is the most prior group. That is COH. Then comes SO3H. Then comes COOR. Then comes COCl. Then comes CONH2. Huh? Then comes CN. Then comes CHO. Then comes C double bond O, that is ketone group, right? And then comes NH2. So these are the priority level. So out of this, let me explain the which option is correct, beta. That is in option A we have COH and then comes CONH2, then COCl. So this is not the correct one because COCl is most prior than CONH2. In the second option, we have SO3H, good. Then comes COCl, very good. Then comes CONH2, good. Then comes CN. So this is absolutely correct order, right? This is absolutely correct order. Let me explain the option C and D as well. In option C, we have COOR, fine. After COOR, we have a COCl, fine. After COCl, we have NH2 and then CO. This is not done because ketone group is much more prior than NH2 group. So this is wrong. In option D also, we have COH, right? Then comes COR. This is also right. Then comes CONH2. Then comes COCl. This is not true because COCl is much more prior than CONH2, right? So which option is correct, beta? Only option B is correct. ठीक है, समझ आया सबको? Why only option B is correct? Got it? सभी को? सो ये प्रायोरिटी ऑर्डर आप लोग सभी याद रखेंगे, ठीक है. दिस इज द प्रायोरिटी ऑर्डर वाइल नेमिंग, IUPAC नेमिंग, ठीक है. ये सबको याद रख लेंगे. सबसे ज्यादा हम लोग किसको करेंगे? COOH को करेंगे, ठीक है. डन. चलो, नाउ move to the next question, that is arrange the following in decreasing acidic strength. So you have to arrange them in order of their decreasing acidic strength. So this is very much simple question. We already discussed this thing. Acidic character depends upon the electron withdrawing group. As more number of electron withdrawing group is attached, then acidic character also increases. ठीक है. तो चलो फटाफट फटाफट देख लेते हैं. माइनस आई इफेक्ट को देखना है बस और कुछ नहीं करना. So here we know this is the electron withdrawing group. This is also electron withdrawing group. This is electron donating group. This is also electron donating group. Now, we know a very important thing here. What we know, beta? The important thing is as the as the minus I effect creating group, as the minus I effect creating group increase. Done. So as the minus I effect creating group increase, क्या होगा बताओ? As the minus I effect creating group increase, acidic value increase, acidic character increase, acidic character क्या होगा? Increase होगा, right? Acidic character increases. And minus I effect creating group means what, beta? That is electron withdrawing group. I'm talking about electron withdrawing group. Like NO2 we have, halogen we have, CHO we have, COOH we have, CO we have. These all are the electron withdrawing group. So as the electron withdrawing group increase, this acidic character also increase due to the minus I effect creating group. Hmm? Now, here also we have a NO2 group, that is a minus I effect creating group. Here also we have minus I effect group. So out of these two, which will create most, most, their power is more, or we can say that which will is more effective, और मेटा पोजीशन पे जो NO2 लगा है वो, या पैरा पोजीशन पे जो NO2 लगा है. So it is very important to understand one important note here. Whenever, whether it is an electron withdrawing or electron donating, whenever they attach to the para position, they always show their मैक्सिमम कैरेक्टर. मतलब अगर NO2 लगा है पैरा पे, तो वो वहां पे ना, और एक जगह लगा है मेटा पे, तो NO2 जो पैरा पे लगा है वो हमेशा, दे ऑलवेज क्या करेगा, इलेक्ट्रॉन विड्रॉइंग ग्रुप को बढ़ाएगा और एसिडिक करेक्टर को बढ़ाएगा. यानी व्हेनेवर इलेक्ट्रॉन विड्रॉइंग ग्रुप अटैच टू द पैरा पोजीशन एज कंपेयर टू मेटा, दे ऑलवेज इंक्रीज द एसिडिक करेक्टर. ठीक है. Yani both the effect were more effective at the para position, where electron withdrawing group attached, where electron donating group attached, but both the effect are more effective at the para position. मतलब डोनेटिंग ग्रुप का काम क्या है, एसिडिक करेक्टर को कम करना. तो अगर वो पैरा पे लग गया तो बहुत ज्यादा कम कर देगा. उसी तरीके से विड्रॉइंग ग्रुप का काम क्या है, विड्रॉइंग ग्रुप का काम है एसिडिक करेक्टर को बढ़ाना. तो अगर वो पैरा पे लगा है तो ज्यादा बढ़ाएगा. यानी बोथ द इफेक्ट आर मोर इफेक्टिव एट पैरा पोजिशन एज कंपेयर टू देयर मेटा पोजिशन. समझ गए. सो सबसे ज्यादा यहाँ पे कौन होगा, एसिडिक, दैट इज फर्स्ट वन. सो एसिडिक ऑर्डर इज लाइक ए इज मोस्ट एसिडिक, देन कम्स बी. नाउ आउट ऑफ सी एंड डी बोथ इलेक्ट्रॉन डोनेटिंग, उसमें भी सबसे ज्यादा कौन कम करेगा एसिडिक को, जो पैरा पे है, यानी डी सबसे कम होगा, देन सी, देन डी. So this is the correct order, right? That is decreasing order they are asking, na, right? So on the decreasing order you can say that the order is like A, B, C, D. So the correct option is option A, right? So option A is absolutely correct for this. That is A, B, C, D. So this is the correct option. Clear है सबको? Done? ठीक है. तो चलो चलते हैं नेक्स्ट पे अब. Now, the correct IUPAC name of the following compound. So you have to name the following compound according to their IUPAC name, correct IUPAC name. So first of all, you need to identify which functional group is attached to this compound. So here we have aldehyde group. We all know this is an aldehyde group, right? So this is aldehyde group. This is aldehyde group. This is ketone group. This is we have ketone group. Here we have alkene and here we have NO2. So this NO2 generally act as a substitute. So out of aldehyde and ketone, preference किसको दोगे? जल्दी बताओ. Out of aldehyde and ketone, preference will be given to those. Which of the following compound? Aldehyde or ketone? Obviously aldehyde, right? अभी हमें सीक्वेंस पढ़ा था पूरा. ठीक है, यहाँ पे देखो. Yeah, this is the sequence where we have aldehyde and ketone. So preference किसको देना है? Aldehyde को. चलो. So aldehyde is given preference. So aldehyde act as a functional group here. So start the counting from here only. That is 1, 2, 3, 4, 5, 6. So we have 6 carbon here, right? More than 6 kya? Let me count again. 1, 2, 3, 4, 5 and 6. 6 ही हो रहा है. Yeah, that is 1, 2, 3, 4, 5, 6. Yeah, 6 carbon we have in this case. So the correct name is, that is hex. ठीक है. Uh, Let me again take the longest chain, that is 1, 2, 3, 4, 5, 6, and here 7 we also have. Yeah, this is also a carbon now. So this is the longest chain, right? So not 6, we have 7 carbon in this. So 7 carbon means क्या हो गया? सीधा hapt, hapt, and 1, 2, 3, 4 we have in. So hapt 4 in, right? So we have a hapt 4 in. And al we have, so we can say enal, right? So this is hapt for enal, enal, al for aldehyde, en for the alkene group. So this is hapt for enal. Now we have a substitute like that is in position fourth. In fourth we have a methyl group. In sixth, we have a nitro group, right? And three, we have a oxo group. So this is oxo O, methyl M, and nitro N. So out of, if you're maintaining the alphabetical order, then you need to write the name methyl first. So this is like 4 methyl, 4 methyl, right? So this is 4 methyl, and then comes 6 nitro, okay? So 4 methyl, 6 nitro, and they are named as 3-oxo, right? 3-oxo. Because whenever ketone taken as substitute, they are named as oxo. So this is 3-oxo. So this is the correct name, right? This is the correct naming. That is 4-methyl, 6-nitro, 3-oxo, hapt 4-enol. Hapt for enol. So which option is correct, beta? Yes, that is option number C. So option C is absolutely correct for this. ठीक है? So option C हम लोगों के लिए बिल्कुल ही क्या हुआ? Correct हुआ इस क्वेश्चन के लिए. समझ आया सभी को क्या? एक बार फटाफट बताएंगे. Done? क्लियर है सबको? किस तरीके से नेमिंग किया? Always remember the functional group priority level, right? If you know this priority level now, then you can easily name the compound. चलो. The next question is, which of the following structures are aromatic in nature? Right. So you have to identify which of the following compound are aromatic in nature. Right. So they have to compare which of the following out of these are aromatic in nature. Okay. So we all know this thing. Those compound which is planar and follow the Huckel's rule, right? And that is 4n plus 2 pi electrons are said to be aromatic in nature, right? So they are said to be aromatic in nature. So out of these, uh, let me calculate which one is planar. So here we can say that this is sp2 hybridization. This is also sp2 hybridization. This is also sp2. This is also sp2. And here also we have sp2 hybridization. Okay, here also we have sp2 hybridization. How? One bond, sigma bond is with this, and one sigma bond is with that is 2, and one negative charge. So 3, 3 means sp2. Right. So that is A and B, right? A and B are aromatic as they are cyclic planar and has 4n plus pi electron. So 4n plus 2 pi electrons, right? 4n plus 2 pi electrons rule they are following. How will they following better? Because we know this thing, we have a 4n plus 2 pi electrons. That is 4n plus 2 pi electrons. So whenever this anything which follow this rule, that is the Huckel's rule, then they are said to be aromatic in nature. So only these two compounds, that is B and A. So only these two following this condition, that is they are planar, cyclic planar, and follow 4n plus 2 pi electrons rule, right? So whenever they are following 4n plus 2 pi electron, they are said to be aromatic in nature. So out of these all option, only A and B following this. Chalo. So in the following structure, which one is having staggered conformation with the maximum dihedral angle? जल्दी से बताओ. This thing I explained you in yesterday class also about the staggered and eclipse conformation, right? So in the following structure, which one having staggered conformation with the maximum dihedral angle. So you need to identify with the maximum dihedral angle. Out of this, which of the following having, right? So let me explain this thing. Hmm? So in the staggered conformation with the maximum dihedral angle, how will you edit? This is the option A. So this is the option A where we have a CS3, and HH we have. This is option B and this is option C. So here we can say that now this is maximum angle here, right? This is here we have a maximum angle. Right, so they all are divided into 3 and 3. That is 90, 90, 90 degree. Right, so maximum angle is present here. Right, so out of these four, the maximum angle is in C. So this is the correct one. That is in the following structure, which one having a staggered conformation with the maximum dihedral angle. So the maximum dihedral angle is shown by this. That is C. Right, so C is the correct option. Now, the IUPAC name of ethyl diene chloride is. So, how will you write the IUPAC name of ethyl diene chloride? So, first of all, you need to draw the structure for this, right? So, how will you draw the structure for ethylidene chloride, right? So, let me draw the structure. CH3, CH, Cl, and this C. Right. So this is the structure of ethylidene chloride. So this is the structure. Now you need to write the IUPAC name. So now I hope it's a very simple to write the IUPAC name. If you know the structure, that is 1, 2. So we have only 2 carbon and in one we have a 2 chloro group. So we can say that that is 1 dichloro. So we have a 1 dichloro, 1 dichloroethane, 1 dichloroethane. So this is the correct name. That is option D. 1 dichloroethane. So this is simple question, but only when you know the structure. When you don't know the structure, then this question won't be able to you won't be able to solve this question, right? So this is the IUPAC name of ethyl diene chloride. Okay, so always remember this thing. Ethyl diene chloride is look like this: CH3, CH, Cl, and Cl. Right? Chalo. Now the next question is arrange the following. ठीक है, arrange the following carbocation in decreasing order of their stability. In decreasing order of their stability. So you need to arrange them in order of their decreasing stability, right? See which one is more stable and which one is less stable. ठीक है, तो चलो देखते हैं फटाफट कि out of these which one is more stable and which one is less stable. So here we have A, B, and C. So we have a total three things which is right. So out of these three, you need to identify which one is the stable. Can anyone tell me the answer for this? Anyone wants to say anything about this? Decreasing order of their stability. Anyone? Hmm? So here, let me explain this. So we know this thing. It's a very important. That is, just wait for a second. Yeah, that is carbocation stability. So basically, the stability of the carbocation depends upon whether they are the primary, secondary, or tertiary, right? So if you considering here carbocation, this carbon, so this is 1 degree, 2 degree. Here carbon we have that is 1 degree, and here also we have a 2 degree, right? Now the important note here is What is the important note here, beta? The important note here is, which is important, and try to understand is this. That is, if you considering this A, B, and C, both these three carbocation, on which factor the stability of the carbocation depends is the hyperconjugation, that is number of alpha hydrogen, right? So if you know the number of alpha hydrogen, then you can easily say which one is more stable and which one is less stable, right? So if I'm talking about carbocation A, पहले A की बात कर लेते हैं. So carbocation A is stabilized by hyperconjugation due to the 4 alpha hydrogen atom. ठीक है, यहाँ पे कितने अल्फा हाइड्रोजन एटम है? 4. चलो दिखाते हैं कैसे है 4. ठीक है. सो यहाँ पे पॉजिटिव चार्ज है. तो जब यहाँ पे पॉजिटिव चार्ज है, ये कोई कार्बन है समझ लो, ये अपना कार्बन है. डन. तो ये कार्बन है, तो यहाँ पे कितने हाइड्रोजन होंगे बेटा? एक बॉन्ड इधर से मिल रहा है इसको, एक बॉन्ड इधर से मिल रहा है, दो. है ना? और यहाँ पे कितने कार्बन हो सकते हैं? तो यहाँ पे दो हाइड्रोजन इधर है, दो हाइड्रोजन इधर है. सिमिलर वे में दो हाइड्रोजन इधर है कार्बन के पास. इस वाले कार्बन की बात करो तो एक बॉन्ड दो बॉन्ड, तो दो हाइड्रोजन तो होंगे. तो अल्फा हाइड्रोजन क्या होता है कि कार्बोकैटायन के नेक्स्ट वाला जो कार्बन है, जैसे ये वाला जो कार्बन है, इसमें कितने हाइड्रोजन है? तो दो और दो चार. तो यहाँ पे अल्फा हाइड्रोजन कितने हैं बेटा? 4 है. तो यहाँ पे अल्फा हाइड्रोजन 4 है एक एक केस में. अगर मैं सी की बात करूं तो सी में भी यही कहानी है. अगर मैं बोलूं यहाँ पे पॉजिटिव चार्ज है, तो इसके साथ ये कार्बन अटैच्ड है, तो यहाँ भी दो और यहाँ भी दो. यानी यहाँ भी अल्फा कार्बन कितने हैं? 4 है. तो इन दोनों में अल्फा कार्बन 4 है. ठीक है. लेकिन यहाँ पे एक चीज ध्यान रखनी है कि यहाँ पे एक माइनस आई इफेक्ट क्रिएटिंग ग्रुप भी है ऑक्सीजन के चलते. है ना? अब कार्बोकैटायन बी की बात करो तो बी में जो कार्बोकैटायन है, वो स्टेबलाइज हो रहा है रेजोनेंस के थ्रू. वहां पे क्या हो रहा है? रेजोनेंस हो रहा है, रेजोनेंस. तो ध्यान से क्या समझना है, ये रेजोनेंस के थ्रू स्टेबलाइज हो रहा है. इन दोनों में अल्फा हाइड्रोजन 4 4 4 अल्फा हाइड्रोजन है दोनों में, चाहे मैं ए की बात करूं या सी की बात करूं. बट सी में एक इलेक्ट्रॉन विड्रॉइंग ग्रुप पे लगा हुआ है, ओ ऑक्सीजन नेगेटिव. है ना? तो उसके चलते भी ये डीस्टेबलाइज हो रहा है. सो द करेक्ट ऑर्डर क्या हो जाएगा बेटा? मैक्सिमम स्टेबिलिटी इज फॉर बी, देन कम्स ए, एंड देन कम्स सी. सो सबसे ज्यादा स्टेबल कौन है? ऐसे भी हम लोग को पता है, अगर इलेक्ट्रॉन विड्रॉइंग ग्रुप लग जाते हैं तो उसकी स्टेबिलिटी ऐसे ही कम हो जाती है थोड़ी. है ना? सो बी, ए एंड सी. So this is the correct order. That is option A. ठीक है. चलो. So the next question is, arrange the following conformational isomer of N-butane in order of their increasing potential energy. So in this question they are asking arrange them in order of their increasing potential energy. कि भाई potential energy के हिसाब से बताओ. सो देखो बड़ा सिंपल सा कहानी है कि स्टेबिलिटी इज इनवर्सली प्रोपोर्शनल टू द पोटेंशियल एनर्जी. ठीक है. अगर कोई ज्यादा स्टेबल है, तो स्टेबिलिटी इज इनवर्सली प्रोपोर्शनल टू देयर पोटेंशियल एनर्जी. जिसका एनर्जी जितना कम होगा वो उतना ज्यादा स्टेबल होगा. यानी हाइयर द एनर्जी, लेसर इन द स्टेबिलिटी. हाइयर इन द लोअर इन द एनर्जी, हाइयर इन द स्टेबिलिटी. यानी मोर स्टेबल, लेस पोटेंशियल एनर्जी. सो फर्स्ट ऑफ ऑल लेट मी एक्सप्लेन द स्टेबिलिटी ऑर्डर फॉर दिस. So what is the stability order beta? Because this type of question we already discussed many times regarding staggered and eclipse form and their stability. So stability order is like one is a stable maximum, then comes three, then comes four, then comes two. So this is the stability order. That is one is maximum stable, maximum bond angle we have in this case 90 90 90 90 degree, right? And then comes third one, this one, then comes fourth, and then comes, because here the angle is very very less, so there is more chances of repulsion. So this is the least stable. Hmm. So what is the order of potential energy? So potential energy order is like two, four, third, and then one. So this is the order of their potential energy, right? Because maximum stability is one now, but they're having the minimum potential energy, right? So the order is like this. So which option is correct? That is D. So option D is absolutely correct. That is one, three, fourth, and second. So this is the absolutely correct answer. समझ आया सबको क्या? जल्दी बताओ एक बार फटाफट. Got it? ठीक है. सो ये करेक्ट ऑर्डर हो गया हम लोगों का। नेक्स्ट चलो बेटा, तो नेक्स्ट चलते हैं। सो दे आर आस्किंग चूज द करेक्ट नेम फॉर द कंपाउंड गिवन बिलो। सो आपको बताना है विच ऑफ द फॉलोइंग इज द correct name for this, right? So first prioritize the group according to the CIP rule. ठीक है, CIP rule से आप prioritize करो ग्रुप को, and it is like the here we have bromine, right? So this is number one carbon, two. So how will you prioritize this group? Because here we have a triple bond is present, double bond is present, right? So this is a different kind of naming. So choose the correct name for the compound. So what is the correct name? So first prioritize the group according to the CIP rule. That is maximum molecular masses like this, right? So this thing we say this is one and this is two, right? Bromine and methyl. So bromine having the molecular mass. Similar we have here with this is the first compound and this is here we have hydrogen. So this is the second. So the name is 2E, right? 2E, 2 bromo, 2 bromo, hex, 2 ene, 4 ine. So this is the correct name. 2E, 2 bromo, hex, 2 in, 4 in. Option C is absolutely correct for this. Now, move to the next question. That is the compound which will show significant intermolecular hydrogen bonding. So you have to check which of the following compound which will show a significant intermolecular hydrogen bonding is and are both are possible. So चलो देखते हैं सबसे पहले. So what do you mean by this term inter and intramolecular, right? So in this they are asking intermolecular. So intermolecular between the two different atom and intramolecular means between the two same atom. ठीक है? So let me explain this. So in case of A show the intramolecular hydrogen bonding, right? Between the two different atoms, right? Between the two different atoms. So we can say that A show the intramolecular. So this is not the correct. Similarly, B we have show significant intermolecular hydrogen bonding. Here we can say that they show the bonding with this, that is this NH and O. So we can say that this will show intermolecular. Similarly, C it do not show intermolecular hydrogen bonding due to the steric hindrance. So here we have lots of steric hindrance. Due to this, they will not able to show the intermolecular hydrogen bonding. So the correct answer is B only, right? That is B only. So only B will show intermolecular hydrogen bonding. So समझ आया क्या? इंटरमोलिकुलर का मतलब ही होता है जब वो आपस में ही शो करे, एंड इंट्रामोलिकुलर का मतलब क्या होता है? So in this question they are asking intermolecular, right? So try to remember this thing. Now move to the next question. That is yeah, this one. Which one of the following compound is not aromatic? So they are asking इसमें से कौन aromatic नहीं है? ठीक है? So which of the following compound is not aromatic? So this thing, this is not aromatic, and why this is? Because here we have 1, 2, 3, and 4. So this equal to 4n plus 2, and this is equal to 2 to 8 electrons. So this 4n is equal to 8 minus 2, which is equal to 6. So n is equal to 6 by 4. So this value comes out in fraction, that is 3 by 2 or 1.5. So whenever the value of n comes out in fraction, they are not an aromatic compound. Right, always remember this thing. So we can say that this is not an aromatic compound. Right. For example, in this phenol, if you want to calculate this 4n plus 2 is equal to 6. So this 4n is equal to 6 minus 2. This is equal to 4 by 4. That comes out to be 1. So whenever the values come like 1, 2, 3, 4, they are said to be an aromatic. Whenever the value of n, according to the Huckel's rule. So here the value comes in a fraction. So we can say that this is not an aromatic compound, right? So the correct answer is C, right? So which one of the following compound is not aromatic? That is C. This one is not aromatic in nature. Chalo, move to the next question, beta. Given below are the two statements. Statement 1 state that hyperconjugation is a permanent effect. That is hyperconjugation is a permanent effect. And statement 2 state that hyperconjugation in ethyl cation involve the overlapping of CsP2 H1s bond with the empty 2p orbital of other carbon. So you have to choose the correct option. Okay, so you have to choose the correct option for this. So let's discuss the correct option. That is hyperconjugation is a permanent effect. So according to this statement 1 and statement 2, hyperconjugation. Okay, so hyperconjugation is a permanent effect. This is very much correct, right? So it is a correct statement that hyperconjugation is a permanent effect, right? So ये तो सही है. Now, hyperconjugation in ethyl cation involve overlapping of this. So basically, they are asking ethyl cation, that is CH3, CH2, and plus, right? So they involve carbon sp3 hybridization with hydrogen 1s bond with the empty 2p orbital. Hence, given statement is false, right? Because with the empty 2p orbital of other carbon, right? So this is not sp2. Instead, they have a sp3. So the statement 2 is incorrect. The statement 1 is correct, but the statement 2 is false. So the correct option is C. Now, next question is that is a stagger and eclipse conformation of ethane. This question is coming, they are coming every time this type of question related to stagger and eclipse form. Whether they are asking for the stability, potential energy, their structure, dihedral angle. So these questions are coming every year. So staggered and eclipse conforms of ethane are. So what they are? They are polymers, rotamers, enantiomers. So always remember beta, stagger and eclipse conformance of ethane also known as rotamers, right? इसको किस नाम से जानते हैं? Rotamers. So they are also known as rotamers. Now, move to the next question. The correct order of stability of the given carbocation, right? So this is this in this question you need to arrange them according to their stability of the given carbocation. That is out of A, B, C, D, which one is more stable and which one is the less stable. Okay, so always remember, due to the resonance, this one is much more stable, right? And here the positive charge is stable on less electronegative element. For example, the order is like that is A is much more stable. Then comes C, right? This one, CH3, CH2. So this is the number one. This is second number. Then comes B, third, and this is fourth. Right. So why? This is very much clear that is due to resonance, they are much more stable. But what factor you need to remember in case of B, C, and D? So always remember positive charge is stable on less electronegative element. So this one is much more electronegative element. After this is also much more electronegative as compared to alkane. So that's why. Always remember that is a positive charge is stable on less electronegative atom, not much more electro. Here we have a more electronegative carbon atom, sp hybridization. Okay. So the correct order is like A. So which one is the correct order, beta? A. So A is the absolutely correct order for this question. The next is the correct decreasing order of density of the following compound, right? So the correct decreasing order of the density of the following compounds. We have A, B, C, and D, and they're asking the correct order of the decreasing order of their density. So how will you find the decreasing order of density, beta? So let me explain this by the molecular masses, right? So here we can say that in this we have a bromine group and we have a chlorine group. So bromine having the more molecular masses, so the obviously density of D is much more. So D is much more. Then comes C, obviously. Then comes B, and then comes A. So A having the minimum. So this is the order DCBA, DCBA. So option A is correct. So this is a very simple question. That is the correct order of densities of the following compound. Now, which among the following is the strongest acid? Okay, so you have to identify out of the following which among the following is the strongest acid. So we know that acidity depends upon the one is electron withdrawing group. So here no electron withdrawing group is present. So we need to consider the second factor here. That is the strongest acid because it is a conjugate base is aromatic. right? So whenever their conjugate base are much stable, conjugate base of aromatic means what? They are stable. So those are the strong acid whose conjugate base are much more stable. So जिसका भी conjugate base सबसे ज्यादा stable होता है वो सबसे अच्छा acid होता है, यानी D। अगर मैं इसका conjugate base का बात करूं तो इसका conjugate base जो है, क्या है conjugate base, इसका क्या बनेगा? तो इसका conjugate base बनेगा, let me draw। तो ये है इसका भाई कॉन्जुगेट बेस, राइट। सो इसका कॉन्जुगेट बेस जो है वो ज्यादा स्टेबल है ड्यू टू रेजोनेंस, है ना। स्टेबिलिटी हो गया, एरोमेटिक कंपाउंड बन गया, इसीलिए ये सबसे ज्यादा अच्छा एसिडिक कहलाएगा, राइट। दैट्स व्हाई दे आर मच मोर एसिडिक इन नेचर। चलो, मूव टू द नेक्स्ट क्वेश्चन, दैट इज विच ऑफ द फॉलोइंग कंपाउंड डज नॉट एग्जिबिट रेजोनेंस। कौन इसमें से रेजोनेंस को एग्जिबिट नहीं करता है, ठीक है। सो विच ऑफ द फॉलोइंग कंपाउंड डज नॉट एग्जिबिट resonance, right? So we can say that in that is A, they show resonance. B also show resonance because they having aromatic compound benzene with us. And if I'm talking about C, they also able to show resonance. Now in D, no resonance. Why? Because no conjugation, this resonance is not possible. So in D there is no conjugation like A, B and C, so we can say that D do not exhibit any kind of रेजोनेंस। ठीक है, चलो। द नेक्स्ट क्वेश्चन इज among the given species, right? Among the given species, the resonance stabilized carbocation, which one is resonance stabilized carbocation? So this type of question we already discussed many times. So we can say that that is in A and in B, right? They are the resonance stabilized. In this resonance is takes place, and due to this they are called resonance stabilized carbocation। सो आई होप क्लियर है यहाँ तक सभी को। अभी तक किसी को कोई भी डाउट हो तो यू कैन आस्क बेटा फटाफट। किसी को कोई भी डाउट है? नो? राइट, सो नो डाउट। या, सो ये हमने क्वेश्चन सॉल्व किए बहुत सारे। सो तुम लोग भी ऐसे क्वेश्चंस को ट्राई करना, एक बार सॉल्व करने का देखो, ट्राई करके सॉल्व करके जितने क्वेश्चंस कर सकते हो। सो इन नेक्स्ट वीकेंड क्लास आल्सो वी आर गोइंग टू सॉल्व सम क्वेश्चन रिलेटेड टू न्यू चैप्टर्स। सो टिल इस जीओसी के क्वेश्चंस को और प्रैक्टिस करना अच्छे से, जितना कर सकते हो, ठीक है। और ट्राई करना कि अलग अलग टाइप्स के क्वेश्चन सॉल्व कर सको, जिसमें कुछ मेंस के क्वेश्चन हो, नीट के क्वेश्चन हो, एडवांस के क्वेश्चन हो, हर टाइप के क्वेश्चंस को ट्राई करो, ठीक है। एंड देखो कौन से क्वेश्चंस ज्यादा ज्यादा बार आ रहे हैं, तो वही क्वेश्चंस को तुम लोगों को करना है। तो थैंक यू, और मिलते हैं नेक्स्ट क्लास में, फिर वहां हम लोग आगे और डिस्कस करेंगे, ठीक है।